All right, welcome to lesson 1.6. I already gave you a warning that I wasn't going to be here today. So we're going to continue with our finite differences, talking about first, second, and third degrees on there, but we're going to save that for tomorrow. So our goal today is to be able to write quadratic equations since we didn't do that yesterday. So I'm going to start with a review of what we did yesterday. So if you look at your notes, you should have this table on there. If you want to pause the video and go back and get the I can statement, just pause the video. Okay, we're going to start with this one. And I'm hoping that all of you take a good look at this one and notice that right away it's linear or arithmetic because we're adding 2. And remember when we write an equation, it's kind of like y equals mx plus b, except we're talking about a discrete points here. So instead of using y and x, we're going to use an equals. And our slope in this case, the rate of change is going up by 2, so I have 2n. And remember, you want to go backwards to find your y-intercept or your 0 term. So instead of adding 2, I'm going to subtract 2, so I get my 0 term of 3. So my explicit formula is an equals 2n plus 3. So if I wanted to find the fifth term, I can just add 2. Then if I wanted to find the 20th term, that means a sub 20 equals 2 times 20 plus 3, which is going to give me 43. So I go back up to my table and write down 43. And I've already found my explicit formula. To find any term in the sequence, I just do 2n plus 3, and I plug in the sequence number I want in for n. Okay, now we're going to look at this one. Oops, we already talked about that. So remember, arithmetic has a common first difference. Okay, first difference. This is not on your notes, it's just a review. Okay, geometric is also known as exponential. We also write that. We think about y equals ab to the, to the x, but we don't really write that. We again use an and n. Okay. Remember, sometimes you're going to want to do the n minus 1 if you don't go back to find that first term. And then the big focus today is going to be on quadratic. It has a constant second difference. That's the key highlighter, okay? So I'm going to tell you right now, if I try to get these, I won't get a constant first difference, but I will get a constant second difference. So that one's going up by 9. That one's going up by 13. That one is going up by 10, 15, 17. And that is going up by, let's see, 21. So I go to the second difference. That looks a little messy. Let me write this better. 9, 13, 17, 21. Go second difference, I get 4, 4, 4. And I often like to write pluses because if it's minus, you do have to include that in your problem. In this case, we have a constant second difference, so this is quadratic. Wow, if I can spell. Woo, it's late. Okay, and that's going to be our main focus today on writing equations for that. I just want to show you a couple more. So I want you to pause the video and see if you can remember how to do the linear equation for this or the arithmetic, because I'm telling you it's arithmetic. So go ahead and pause the video. See if you can write the equation. So I get plus 2, plus 2, plus 2. I have a constant second difference. So if you got your explicit formula to be plus 8, 2n plus 8, then you are correct. And again, to find the 20th term, you plug 20 in and you should have gotten 48. Okay. All right, we did the missing information. Okay. The next one just says name this type of sequence. However, I'm going to take it one step further and have us write a recursive routine, or explicit formula, excuse me. I'm thinking of my other class, explicit formula. So if you notice, the pattern is times 3. So I want you guys to pause the video and see if you can look back at your notes from yesterday and write an explicit formula. And remember, this is the equation we're thinking of, exponential, but that's not the one we want to write. We don't want to write y equals, okay? So pause the video and see if you can come up with the explicit formula. All right, my explicit formula would be an equals, okay? My starting term isn't 2. I want to go backwards. So if I multiply by 3 normally, this time I need to divide. So I hope you guys all can see that our 0 term would be 2/3. So that's my starting value. And each time I'm multiplying by 3, And again, instead of using x, I'm going to use n because that defines that I'm doing term 1, then term 2. It makes it an explicit formula. So if I want to find the 20th term, and remember, if you want to type in your calculator, do 2/3 times 3, that caret key to the 20th. And when you type that in your calculator, you're going to get a pretty large number. It's 232422934. So it looks like it's 2,324,522,934. Again, that's a very large number. I shouldn't ask you to find anything bigger than that because I don't think your calculator will be able to manage it. Okay. So now we're jumping to the things that we need to do, which is to write a quadratic equation. Now this is going to seem scary at first, right? But I want you to bear with it. Make sure you get the notes down. Okay. So I'm actually going to jump back to this, not this one. This one. So we called this one quadratic, but we didn't fill in the missing stuff. So here's what I'm going to do. I want you to make some room in your notes, right? And I'm going to turn this table sideways. So term 1, 2, 3, 4, 5, 3, 12, 25. If you need to use the back side of your notes, go ahead. I'm really just copying the table right now. So it's just turning it on its side, and there's a reason for this. So I still get to my common difference of 4. Right, so I want you to think back to what a general form of quadratic from last year was. Ax squared plus bx plus c. That's the standard form for a quadratic. Right? But remember, in this class, we're not using x's we're using n, so I'm going to write an squared plus bn plus c. Okay? So here's what we're going to do. This is going to look messy. Please pause it whenever you get stuck. So I'm going to start with that generic thing, right? And I'm going to do the same type of table here, term 1, 2, 3, 4, 5, and I'll go up to 5 for this one, and I'll show you it tomorrow. This will be on the board in class, so if you forget to copy it down during the notes, it'll be up there. Okay, so what I'm saying is my n is 1, my term is 1. So what I'm going to do is I'm going to do a times 1 plus b times 1 plus c. Well, that's the same thing as a plus b plus c. Okay. Second one is telling I'm putting 2 in front because that's where I put my value for the term. So if I want to find term 2, I put 2 in front. So that's going to be a times 2 squared plus b times 2 plus c. A squared is 4, or a squared. 2 squared is 4, so I get 4a. B times 2 is really just the same thing as 2b plus c. So instead of having that there, I'm going to move this one up. Okay. Term 3, I'm going to do the same thing. So I'm going to do a times 3 squared, because I'm putting 3 in for n, plus b times 3 plus c. And that's going to be the same thing as 9a, because 3 squared is 9, plus 3b plus c. Now I know this looks like a lot of letters, but I'm basically just subbing in for n and getting a simplified thing. Now this is going to look messy. I've already warned you of that. So if you're falling behind, pause the video. Okay. Same thing for 4, and I'm going to do this one in my head. 4 squared is 16, so I'm going to end up with 16a. B times 4 is just going to be 4b, and I never multiply c by anything, so if you're noticing a pattern, c is always off on the end. The last one, 5 is going in front, so I get 25, because 5 squared is 25, plus 5 times b plus c. All right, pause the video if you got stuck on that and copy this down. And I'm going to make a little bit more room for us. All right, so we're going to do the same thing. If this was term 1, 2, 3, 4, 5, we want to find the first difference. So I'm going to find the first difference between these. So if you look at a plus b plus c and 4a plus 2b plus c, they have the same amount of c's, so there's no more c's. This one has one more b, and this has three more a's. So the difference between those two is 3a plus b, meaning to get from a plus b plus c to 4a, I have to add 3a, I have to add 1b, and there's no more c's that I have to add. Okay? To get from 4a to 9a, I need a 5 more a's. To get from 2b to 3b, I just need 1b. And to get from C to C, I don't need anything more. Okay? To get from 9a to 16a, I need 7 more a's. To get from 3b to 4b, I just need 1 more b. I hope you're noticing the pattern of we're only needing 1 more b each time. So to get from 16 to 25, I need 9 more a's. And again, I still only need 1 more b, right? So now we got our first difference, and notice the B's are all the same, but the A's are slightly different. So we're going to go out one more. Need a new color here. Okay, we're going to go out one more. Notice now all my B's, I don't need any more along this row, so I'm not going to have a difference of B's. But to get from 3A to 5A, I need 2 more A's. To get from 5A to 7A, I need 2 more A's and no more B's. To get from 7A to 9A, I need 2 more A's. Okay, so this is the chart you're going to need in your notes right now. Okay, so pause it if you don't have it. Now we're going to compare this chart to the one we did beforehand. Okay, so if we look at that first chart, I want you to just look at place values right now. 4 is the same place as 2A is in ours. Even though there's lots of letters, you guys should agree that 4 is the first second difference, just like 2A is the first second difference. Okay, so my first equation is going to be 2A has to equal 4 because they're in the exact same spot. If I look at 9, I hope you notice that that's the first difference. So I look over at my table, and that position in my table is 3A plus B. So I know that 3A plus B has to equal 9, right? And then lastly, I look at the 3 spot of my table, and that matches up exactly with A plus B plus C. So that means A plus B plus C has to equal 3 in my equation. Okay, so I know this is a lot of letters, but so far all we've done is do a generic table, and it's a lot of letters, but we've just found the first and the second difference. And now we're just comparing the steps of that kind of ladder looking thing to our original problem. So we've developed 3 equations here, all right? So the easiest way to start, that 2a equals 4, you should all be able to tell me what a equals. Divide by 2 on both sides, we now know a equals 2. All right? Now that I know a, think about why we did substitution and elimination. We really like to focus on substitution because now that I know a, I can plug it into my second equation. So my second equation is going to look like this. 3, I now know a is 2 plus b equals 9. Forgive me, I'm going to need to scroll down to give us some more room. Don't forget about that third equation. Okay, so I get 6 plus b equals 9. So I'm just going to subtract 6 from both sides. And I get b equals 3. So I now know a equals 2, b equals 3. And now we get down to that third equation. I'm going to substitute 2 in for a. I'm going to substitute 3 in for b. So all I have left to solve for is c. Oopsie, I don't want to separate those. Hold on. Let's group that together. All right, so if I go up, we've already said we're going to plug 2 in for a. I know b is 3. and I don't know C yet. So 2 plus 3 gives me 5 plus C. And then lastly, to solve, I'm going to subtract 5 from both sides. C equals negative 2. Okay, so I've got my A value, my V value, and my C value, right? And we're in the perfect spot here. Pause if you have questions to see if your neighbor can answer them. If not, again, your goal is to get the notes down, and I will be back tomorrow to answer questions. Right, so the last thing we need to look at is, remember we wrote down that standard form of a quadratic is an squared plus bn plus c. Well, we now know that a is 2, b is 3, and c is negative 2. So I'm going to write my generic equation. An is always what I start my explicit with. I know that the a, so this is my generic for any quadratic, but I know that a is 2, I know that b is 3, and I know that c is negative 2. So we've now written our generic equation here just by going through this process. Now, the lengthy part of the process is this table. But this is going to be up on the board, so you don't ever have to recreate this table. The part you have to do is compare the positions that you have. So if 2a is where your 4 is, that's what you set 2a equal to. If 3a plus b is where your 9 is, that's what you set that equal to. And then it just becomes a solving game. Okay? So we're going to try one more. I know this video is getting a little lengthy. Right, I'm going to show you one more, but I'm going to copy the table over first so we don't have to redo it. All right, so I'm going to leave this table up so we can look at it so we don't have to recreate it. And what's helpful for us is to turn our table sideways. So in your notebook, I'm going to turn this sideways. Right, and I'm just going to write down our differences real quick. Go ahead and do it if you have yours. You should have done this one yesterday in class and gotten a difference of 12. So here's the easy part. We've already set this table up. So notice my 2a has to be equal to what? You should all be saying 12. So 2a is in the position of 12. Then I notice that my 3a plus b is in the same position as 23. So I'm going to set 3a plus b equal to 23. The last thing I notice is that a plus b plus c is in the same position as 12. So I have a plus b plus c equals 12. Right, now pause the video real quick, see if you can solve those. You should have gotten a equal to 6. Your next step should have been to go down here and say, okay, I know what a is. So I'm going to substitute in here. So it's going to be 3 times 6 plus b. Right? So we color code this like we had before. So all I've replaced is a with 6. So I get 18 plus b equals 23. So b should equal 5 if I subtract 18. And the last one is nice because I now know that a is 6, b is 5. So a is 6, b is 5. And now all we have left to solve for is c. So 6 plus 5 is 11. If you subtract 11, you should get c equals 1. Now that you have all of those values, you're going to go to your generic equation. So an equals an squared plus bn plus c. And we're just going to replace the values. A we know is 6. B we know is 5. And C, we know is 1. So my final explicit formula is right there. Now I know that's a lot to do today. If you don't get through all of it, at least get your notes down. Try your homework. You can skip those last two. We did them in class at the end. Try your homework, which is just going to be numbers 1 through 3. At the very minimum, I need you to identify the type of sequence and show all your work. And then tomorrow, if you need help writing the equation for just quadratic, you should be able to try them, and you should be able to do the linear and geometric sequences, okay? So I hope this video was helpful. If not, again, your goal is to get the notes down, and I will see you tomorrow.